Okay, so we saw that when you have a multi-threaded blocking IO server, you basically end up spinning up infinite amount of threads, right? And which gives you a huge spike in your memory. So eventually you will be running out of memory and your server will crash. But in production grade servers, we don't really spin up one thread per connection. Okay, we have a thread pool. We have a thread pool where the connections are being distributed, and those threads in the thread pool actually handles the connections, handle the requests. So what if we run into a case where we have a limited amount of threads and all the threads are actually blocked? Then what happens? All right, let's see what happens. So here I have this server, which is basically sleeping for 5 seconds, which is blocking. And now, where am I? Yeah. Okay, so we can see in this server we have 100 threads, right? So that means you will have 100 workers or 100 threads, and every request that the server will receive, those requests will be distributed into those threads. Okay. Now, if all those 100 threads are busy, what will happen then? Okay, let's see what happens. We have already run the server, but let me just restart those servers again. This is the htop and Docker stats. Let me see the Docker stats here. Okay. Um, yeah, so then currently we are having three processes, so the PID is three. Here we have a very simple client, which basically um, makes 1,000 requests with 100 burst of request. It makes a burst of 100 requests and then it waits for 1 second and then it goes to the next burst. Okay, so let's just do it. Okay, yeah, we are spinning up. We are spinning up threads. We have spin up 103 processes. That means like three were before, now it's 100. That means we have spin up 100 threads. All right, let's see what happens when those threads get blocked. Since we are using blocking IO, so we are actually not we're not observing much CPU usage, but we are seeing a spike. Probably that's for the context switch in the kernel usage. But anyways, we are receiving errors. We're receiving errors, right? That means those connections are not being handled. Now let's observe something interesting. Docker restart. And let's just close this. Let's see another matrix here. Um, Let me just do it right here. XEC. Um, Multi-threaded. Okay, so when you are receiving, like connections, but you don't have the resource, you don't have the handlers free for handling that request, handling that connection. Your connection gets queued up Your connection gets queued up into a backlog queue. Okay, and this is exactly what we will observe. We will observe at some point. Let me just fix this a bit. I have made it for 1 second, but it's not. It's 0.1 second. Yeah. So at some point of the request, at some point of the load, we will observe that this receive queue will spike up, and it will reach its limit, and then we will start experiencing the error. All right. Okay. Let me just again show the Docker stats here. We have, yeah, we currently have three. Let me see if I can. Okay, let me just put it here. Just put it here. Yeah. Okay. Um, you see, we're seeing some spikes here, right? We're seeing some spikes in the receive queue, but we're not seeing spike in the threads, number of threads. It's fixed. We are piling up the connections because the threads are fixed and we are blocked. So we are piling up, we're stacking up those connection requests. We have reached our limit, and now we will start experiencing the error. We have reached our limit. Yep, we have experienced the error because those connections were blocked. I mean, those connections were no longer being accepted because because the queue where your connection will be staying after the connection is initiated, that queue is full. Now, now those connection has no place to stay after the TCP handshake. So those connections are dropped, and you're experiencing the error. All right. Now let's see if this happens on a server where we don't restrict the number of threads. So we have a multi-threaded development server, which basically spins up as much as thread as possible. It does not have a thread pool. It does not. It's not limited to a certain number of threads. Okay, just dev server, and sorry. Let me show the stats here. Multi-thread dev server. Yeah, and here dev HTTP server. Okay. Now let's observe. First of all, let me change the client. It's now going to be sending request on port 8002. So yeah. Now let's see what happens. So what we should experience is that the number of threads will spike up because we're not restricting the number of threads. The receive queue will not starve and will not be piled up like the way we observed in the last example, in the case of multi-threaded fixed amount of thread blocking IO server, right? Let's see what happens. We are increasing the number of threads. We are piling up the number of threads, but we are not feeling the pressure here. We're not, like piling up the connections. We're not starving here, right? We are like feeling a bit pressure, like it's queuing for a certain amount of time, but like it's just a glitch. Like it's just coming there and it's just being received by the threads. And this is happening because we are actually observing this within every zero point 0.1 second. If we would have observed this for 1 second interval, then we would have definitely not observed this. But anyways, we're not, like spiking up like the previous example. Yes, but anyways, we do have experienced some errors. It's probably because the backlog size is very less. So probably at some point it spiked up to more than 128 probably, and then it actually fails some. It actually fails some connections. Yeah, but anyways, the thing is like it's a very low amount of failures. But if we increase the size of the backlog queue, it will also be gone. But anyways, the thing is, when you have an infinite amount of threads, you don't limit the number of threads. You don't have a thread pool. You end up with infinite amount of memory usage. When you have a fixed number of threads and you avoid the infinite amount of memory usage, you control the infinite amount of threads, you control the infinite memory usage, you lose connections because your connection queue, your backlog queue gets piled up, and there is no longer space left for making any more TCP connections or for making any more TCP handshake. Yeah, so that's it.